I see a perfect square trinomial, don't you? You could do this if you want to. Oh, crap. I don't know where it was. Anyway, we have a perfect square trinomial under the hood. What can we do to a trinomial? We're going to have to factor that, aren't we? If you want to do the x, you can. -6, +9. You can see easily that this is -3 and -3, right? So that means the two factors that we're multiplying together are x minus 3, x minus 3. So we're doing x minus 3 squared. However, because it's a square root, we don't know if it's positive or negative, do we? Because this one might be positive and this one might be negative. This might be positive and this one might be positive. This might be negative, this might be negative. We don't really even know. So if it counts positives and negatives, we're going to go with the absolute value of x minus 3. Make sense? I hope so. Okay, that's if it's a simple operation as the radicand. What if we have a product property? The product of any two things under the radicand is the same thing as saying you get the square root of one factor times the square root of the other factor equals the square root of the whole thing. Make sense? You can factor the radicand and it's still the same expression. Okay, so if we're going to do that here, let's factor 128. This could be the square root of, we could say 64 times 2, right? So we got the square root of 64 times the square root of 2. What's the square root of 64? 8. It's the same as 8 square root of 2. Let's try this one. 48a squared b. Okay. So we know that we have, I'm kind of making those a little long, aren't I? Where's the eraser? Here it is. Okay. 48, we could say 48 is, let's see, is 16 a factor? Yeah, 3. So we could say this is 16 times the square root of 3 times the square root of a squared times the square root of b, right? Well, 16, we could call that 4 times 4. So now we have two 4s. They can go out. The 3 has to stay home. It's alone. A squared, that's the same thing as saying there's a times a. They're the same. They can go out. And then b is all by himself. He has to stay home. Make sense? And that's the answer. What about if we're dividing? So if you have the operation on the inside as a division, you can always just break them out and say this is the square root of 36 divided by the square root of 4. Or you can say 36 divided by 4 is 9. Whichever one's going to work for you, and then you're going to end up with the same answer, right? Let's try some. 5 and 4. This is the same thing as saying the square root of 5 over the square root of 4, correct? What's the square root of 4? 2. What's the square root of 5? Don't know, don't care. You can have a square root on the top. We're going to leave that up there. There's no perfect square that's a factor of 5, so we're just going to leave it just like it is. Okay? Now let's look at this one. Now we have m on top. And we have 9, which is 3 times 3, and then another m on the bottom, right? These m's are going to cancel. These m's will go out. 2 become 1. These 3's will go out. M over 3. That makes sense? Let's try this one. 12, so the perfect square that's a factor of 12 is 4. 4 times 3. What about 27? 9 times 3, right? So the square root of 4 times the square root of 3 equals the square root of 12. The square root of 9 times the square root of 3 equals the square root of 27. Well, I see right away that these guys can go. They're the same at top and bottom. What's the square root of 4? And the square root of 9 is 3. That simply turns into 2/3. You get the square root of 36 over the square root of x to the 4th. The square root of 36 is 6, right? And this is 4 x's, so that means there's 2 sets of 2, so that's x squared. 4 divided by 2 is 2. Let's try this one. If we want to do it the long way, we got y, and 4 would be we got 2 and 2. Okay, these two y's go out, these two y's go out, those two y's go out. There's 3 sets of y's, so that's y cubed. And here I have 1 set of 2's. And I don't have a fraction under the hood, and I don't have a radical as a denominator, so that's nice. It's done. Very, very nice. Try these. So we've got the square root of 108, the square root of 25. Well, I know the square root of 25 is 5. 108. What do you think that could be? That could be the square root of... Oh. 4 times the square root of 9 times the square root of 3, right? What's the square root of 4? 2. Square root of 9, 3. 2 times 3 is 6. Square root of 3 over 5. There's no radical in the denominator. There's no perfect square that can be factored out. This thing is simplified. Next, square root of 9, square root of x cubed. Square root of 9, square root of x cubed over square root of 16. Well, we know the square root of 9 is 3. Here's 3 x's, so 2 of them can go out. That's going to leave you 1 x at home alone. The square root of 16 is 4. There's no perfect squares that can be factored out. There's no radical in the denominator, and there's no fraction under the hood. There's no fraction as a radicand. So that one's done. Let's go up here. 20 is the square root of 4, square root of 5. 49. Oh my goodness. Oh, got it. This is square root of 7 times the square root. 7 times 7, right? It's 7. So square root of 4 is 2. 2 square root of 5 over 7. Why did 49 just give me a brain cramp? Make sense? There's no perfect squares that can be factored out. There's no radical in the denominator. There's no fraction under the hood. We are simplified. And I think we are ready. I got some practice for you. Okay? Good luck. Call me or let me know if there's any problems.